Where do the world's top data scientists and machine learning engineers think AI is really heading? How can you join them and break into your own data science, machine learning, or data analytics career? Those questions are what we're all about. My name's Jeremy, and welcome to the Mind the Machines podcast.
No matter what institution you're coming from, you can get access to the very latest research.
We also have to make sure that we're constantly revisiting our foundations and justifying why we're using the methods we are.
It's hard not to employ you. It doesn't matter what field you're in or what is it that you're good at. If you're good at something, if you like something with passion, there is someone who really needs you.
All right, welcome to the podcast. This is the place where we talk about the future of machine learning and what aspiring data scientists and ML engineers can do to jump into the field today. So one of the key things that I wanted to talk to you guys about a little bit was maybe starting with you, Ed. What is it that you've noticed that aspiring data scientists usually don't get about the job market?
Applying for jobs is a totally different skill set from actually doing the job itself. Applying for a job, the interviews, the resume screening.
This is my brother Ed. In 2016, we co-founded a company that would eventually become a mentorship program for data scientists called Sharpest Minds. Like me, Ed used to be a physicist until he took the deep plunge into data science and startups. Ed's the kind of guy who puts off watching a season of Game of Thrones until every single episode is out, but who won't snap at you if you let a spoiler drop here or there by accident. So can we dive into that a little bit more? Like, what are the things that you have to learn in order to apply to get these jobs that you don't then have to perform when you're on the job?
So some of it is just the standard kind of engineering coding interview stuff. Like you'll still get data science interviews where people ask you to sort a linked list or other kind of leak code type challenges. All that stuff is not what you end up doing on the job itself. On the job itself, it's much more important to be able to scrape data and clean data and some often deploy things on the cloud. Actually doing data cleaning, data scraping is 80%, 90% of what you will be doing day to day. So to be real, that's what you need to be good at. You're not ever going to sort a linked list because those kinds of whiteboard coding questions all refer to stuff that has kind of already been done for you and abstracted away for you in APIs that you're just going to use. In some cases, maybe it helps to go down to the bare metal, like in certain positions for certain jobs. If there's a company that's reinventing chips for deep learning, of which there are many, like it can actually matter whether you know how the infrastructure works and how the algorithms work down, like right to the bare metal. But for the vast majority of these positions, what you'll actually be doing on the job is just like digging through data and cleaning it and fixing little mistakes and sometimes collecting data yourself.
Which is pretty big contrast, right? I mean, that is totally different from what most interview questions are like. And Russell, one question I wanted to ask you too was, because you've sort of gone through this journey along with us. I mean, the three of us have been kind of navigating this weird path for a while. Why do you think this is the case? Like, why is it that there's such a big difference between what happens on a job interview and then what happens when you show up to work on Monday and you actually have to solve a real data science problem?
I think we assume that interviewers know what they're doing when they interview, and I think that's a big assumption.
This is Russell. He taught himself software engineering and data science after dropping out of grad school and joining Sharpest Minds in the early days. Russell's our team's resident self-improvement and productivity guru. He has a unique way of thinking about productivity and self-optimization that actually makes the topics interesting. He's also into all kinds of metal genres whose names I can never really remember.
There is no set of questions that will give you the answer, like, is this candidate the right fit? Just interviews in general are a blunt tool.
Yeah, a lot of variability as well from company to company, and I guess even within companies. Like, we've talked to a lot of mentors. For me, one of the conversations that really that really kind of stood out was we had a chat with Meng Lin. So she's a mentor who works with Amazon, and she was saying like she has this very specific, very interesting interview style where she asks really simple questions, and then she expects people to sort of like go from this simple premise and go really, really deep. and explain sort of in super detail why some, why a certain model might work on one data set and not on another. Whereas you have like completely within the very same company, completely different kind of interview style when you talk to a different person. And so I think there's a lot of like interview hacking that's a real waste of time, where people start to focus on like just the absolute wrong stuff. Like they waste their time on meaningless crap. These like, not to say that the top 100 data science questions that you'll find on Medium or wherever aren't good, but it's just that there's no silver bullet. I think, to Russell, to your point, I think there's so much variability.
And there's this concept of the interview anti-loop, which I think was coined by Steve Yegg from his days at Amazon. So what he says is that for every engineer, like for me as a senior engineer who interviews people, like let's say I'm an engineer and I'm interviewing people regularly, there is a set of engineers who would be my interviewers at Amazon on any given day that exists that would never let me into the company. No, not in a million years. Like for whatever quirks they have of interviewing, I've been let into this company. I've been let into this system. But if I had just drawn an unlucky lot on my interview day and gotten these engineers, there's no way they would ever have let me into the company. That's how inconsistent it is. And he did this by going around and asking people and trying to figure this out. But that's how inconsistent it is, that even within one company, it's not just like, oh, on any given day it could be wrong. It's that these specific people would always just like absolutely never want to work with you.
So then, okay, that kind of leads to the next question, which is like, how do you prepare for an interview if there's no consistency?
So I think it's just generally good to be knowledgeable about the field that you're in, right? So that you're able to comfortably have discussions about the topics that you're interested in, that you want to work in, which kind of makes sense. And so you need to be able to hold a conversation. I think that's like the number one thing, because that's generally, if an interview feels good, it's because you get a good cadence with the interviewer. And it takes a while to get this kind of confidence, I think, by doing a bunch of interviews. But if you treat it more like you're interviewing the company, like what kind of work do they need? Like, why would they need you? I think that's the right way to approach this thing.
Yeah, I think there's some truth to the fact that the interviewer is always thinking in their own mind, like, look, if I say yes to this person, if I let them through, I'm going to have to sit next to them on Monday. And like, I'm going to have regular casual conversations about real machine learning problems with them. So when you're having that interview, a lot of the time, that's the thought process. Like, are we having a constructive conversation? Are we able to make progress solving problems that maybe neither one of us knows how to solve right now? And I've definitely heard that used actually as an interview style at some of the kind of more cutting edge startups that are really focused on bleeding edge deep learning type stuff. They're really wondering, like, can we collaborate right now to solve a problem that's in front of us that neither of us really knows how to solve?
Yeah, and if you're someone who's applying to these positions, in a way, just the knowledge that things are super inconsistent and incoherent gets you 80% of the way there, because you need to be, you need to have a mental state where when you get rejected by one of these companies, that's a noisy signal. Like, it could mean, yeah, you should go back and go like, okay, what did I do wrong? What could I have done better? Blah, 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 all that stuff. But at the same time, keep in mind that the process that you're jumping into, like, you're jumping into a very imperfect machine that doesn't exactly know how to evaluate you. So you're playing a game of although the lottery balls are kind of bouncing around, and to an extent, the outcome you get is indeterminate. You don't know what's going to happen to you. And just the knowledge of that, and allowing yourself to take a step back from the process and realizing, hey, it's normal to be rejected a whole bunch of times, especially at first. Not just using it for practice, but even if you are the world's most perfect interviewee, you're gonna find yourself in a room with a guy who's woken up on the wrong side of the bed. You're gonna find yourself in a room with someone who spilled coffee on themselves in the morning. Everyone involved is a human being, and the incentives around the interviewer aren't directly aimed at assessing you perfectly accurately. They're incentivized to make sure they keep out really bad people, and that's pretty much that's the strongest incentive they have. They're a lot of them are looking for reasons to say no, but your advantage is you're only looking for one yes. Once you have one yes, great. That's the only yes you need.
Now, in terms of the, because we've alluded in different ways to the fact that the process is really inconsistent, that you can have, and we've seen this a million times. You got like people who you'll mentor, and they're amazing. You see them go, they have wicked technical skills, they're able to communicate really well, and yet they're still not getting traction at first. Now, one thing that you might wonder about is like, okay, why is this happening? Why is the process so inconsistent? And I think I wanted to touch on the point that Russell made earlier about the leak code style questions, and the fact that often you get these kinds of weird software engineering type questions when you're applying for a data science role that can often cause good data scientists to stumble. And I think this is a big source of that kind of inconsistency, where you just show up to a job interview and they're asking you questions about stuff that seems irrelevant, like optimize this list sorting algorithm. And it's like, well, when am I ever going to use that when I actually go to deploy a machine learning model at scale? It's just not going to happen. I think one question that you have to ask at this point when you look at the field is, why is this happening? Why is it that you can actually expect to get leak code questions if you walk into big company X on your very first interview? Why can you sometimes expect to have leak code questions in a context where you're really just applying to be a data scientist, and there's no application in your day-to-day of those kinds of problems? And like, we've talked about this a lot because we've seen it a lot, but as far as I can tell, this just has to do with the fact that a lot of companies just see data science as a job where you hire people who code. And so there's not much more analysis than that. They're like, all right, well, what do we do with all the other applicants who have to code for a living? Well, we ask them leak code questions. So I guess we're going to ask these people leak code questions because they're going to code on day one. And anyway, it's just like, I think that's an artifact of how still relatively young this field is. And that's part of why we haven't yet coalesced as an industry around a single set of best practices, the same way we have in software engineering. Like interviews are a little bit more predictable, at least.
I mostly agree, but I do think the definition of data scientist is so broad that it does include like a small subset where you do need to know the answers to these lead questions, where you do need to be like a super proficient programmer. So those cases do exist, but like still, unfortunately, because there's no good naming convention for these positions, you end up getting data scientists who aren't expecting these kind of questions. I think that's part of it. And I think like software development has the same problem. You don't need to be optimizing like these kinds of algorithms if you're just doing full stack web development generally.
Yeah.
But you'll still find questions like this in interviews for those types of.
Well, and that's a good point about the distinction between roles, because this is something that comes up a lot too. People will apply to a data science role. It's advertised as a data science role, and then they'll find out that it's actually a machine learning engineering role. Or in other words, a role where, and maybe this is more the kinds of roles you're talking about, where lead code questions become relevant, where you're optimizing a model, deploying it to production, really making sure that the inference time is short, that you can train it fast and all that, compared to, say, a data analyst role where it's more about visualization and data exploration and all that. But they all tend to fall under this data science bucket that for some reason we just as an industry want to cram everything into the data science bucket, and it's just led to so much confusion. I feel like it's one of the biggest problems we have in the field.
That's a good point. I've heard data science used to describe everything, literally everything.
Let's get into definitions for a second here, because I have, obviously I'm very biased. I have my own views, and we've talked about this a little bit internally too. But what is your definition of, let's say, what a data analyst is versus a data scientist? I think that's one of the biggest kind of boundaries that people have a hard time drawing.
I'd be interested to hear what you think, but in terms of analyst versus data scientist, so I've always thought of an analyst as someone who goes and digs through data, but stops short of building explicit models. Like someone who generally is like, okay, let's break out the stats of this data, maybe like make a dashboard, maybe make it, in the limit, make it, visually accessible to some decision makers, and just like show the charts, show like the first level, the surface level of the data, which is usually super interesting. There is almost always some low-hanging fruit available when you just do that, and tons of value to be had. Whereas a data scientist, in the least all-encompassing definition, might be someone who takes the same data set, but applies some extra little fancy stuff to it. So does some kind of clustering, maybe even does some deep learning, but builds a model, puts it on top of a data set, and then looks at what comes out. As opposed to a machine learning engineer where it tends to be more you're productionizing a system. So it's no longer like, oh, you need a person to put these pieces in place, but you've built a system and a process to ingest data and then have your app or your system, whatever it is, use it on the back end.
I mean, that's pretty in line with the way I tend to think of it. Like, I've tended to look at data science from a life cycle standpoint as being divided into 4 different steps, 4 different stages. Like the first being getting the data. And I mean getting in the most general sense. So acquiring and then managing and kind of cleaning and warehousing the data. That's where data engineering comes in. Once you get the data, you have to understand the data. And that's where you do your data exploration, data visualization, maybe some dimensionality reduction stuff like PCA. To me, that's where the data analytics comes in. That's where you have your data analysts. After you've done your getting the data and understanding the data, you got to model the data. And if you're building predictive models, to me, that's really the heart of data science, is where you start to, you whip out your Jupyter notebook, you're really optimizing your modeling software and all that stuff. And then the final step is actually using your data in production in the form of deployed models. And so that's where we get into, at least in my opinion, that's where the machine learning engineers come in, the people, as you said, who are focused on this productionization. Whether or not people use these definitions, I feel like as an industry, we need to figure out some consistent definitions so we don't have people applying to data engineering jobs that are labeled as data science jobs or whatever. I feel like that's such a big problem.
Yeah. Okay. So one question here is, we all know that data science is a space where personal projects are especially important in getting people's attention when you're trying to get hired. If you can build a model and something that's original, visual, all those things, you stand a better chance of getting someone's attention. So my question is, what kinds of projects do you guys think are particularly good for getting people's attention?
So the first thing to remember is recruiters, technical leads, they see all the same projects all the time. And what projects am I referring to here? I'm referring to the kinds of projects that you would expect the statistical average or median data science applicant to have done. So things like MNIST, the Titanic dataset, the IRIS dataset, if these things sound like things that you've spent a long time playing with, that's because everybody's playing with them. I mean, these are the default run-of-the-mill datasets that everybody beats their head against the wall on. Until they're ready to sort of do something more interesting. And one of the biggest mistakes I've seen people do is focus on those for too long and not go out and build original projects. And original projects means not just going on a new kind of data set repository, like instead of using MNIST, go to Kaggle and pull off whatever the latest competition is, because everybody else is doing that too. Original, ideally, means collecting your own data. And that means getting good at scraping. That means understanding how to use APIs. It's all the dirty part of gathering your data, of being a data scientist. Because the reality is companies know on day one when you show up, chances are you're not going to have a data set ready and waiting for you. You're going to need to go out and find the data, think of what data you'll need to solve a problem, and then find that data yourself. No one's going to do that for you. So you got to be able to show you have the ability to do that. And you also want a project that is something that a recruiter hasn't seen before. Something that makes them go, oh, wow, that's interesting. Ideally, even something that they can understand the value of. So if the project has some crazy complicated math title that's not going to mean much to anyone, that doesn't have as much value as this app is going to tell a hot dog apart from not a hot dog. Except imagine that was a more original idea. So that's kind of my 2 cents on that. Is originality is probably the key factor.
Yeah, I would agree. I think data collection is underrated.
Yeah.
Because the skills, first of all, it gives you an appreciation for the work that goes into a nice clean data set, right? And it's a lot of work, or can be, because not only do you have to define sources and set up a pipeline to collect it, but there's also a lot of cleaning involved. And you hear from data scientists, 90%, maybe that's too much, 80% of their time is spent collecting and cleaning data. That means getting the data into some format that your machine learning model can actually consume and make meaningful predictions from.
think another thing you mentioned was it being understandable. I think that's actually really, really important. I was actually speaking the other day to a mentor who was applying to us, and he was telling me how his first job out of university. So in university, he had built this giant ERP app, like this giant backend enterprisey app of 20,000 lines of code. And his university or whoever their career services / professor or something had told him that, hey, this would be super impressive to recruiters because it was so big and so complicated and it showed he could do so much. But the thing is, when recruiters started looking at it, they couldn't understand it because, of course, they don't have time to go through 20,000 lines of code and notice how beautifully, beautifully complicated this is. So what he ended up doing was making this app that could look at your face and tell you how tired you were on a scale of 1 to 10. And so what's beautiful about that is I understand it. I understand what it does. I haven't seen anything quite like this before, which is good enough for me. And it seems like the sort of thing that is at least somewhat complicated to put together based on what I know. And that's all. That's all it takes. That's literally all it takes. Like, can you prove to me that you've done some minimal amount of work that created something novel for yourself? You can't prove that to me by doing something that's not original, because you could just have used a tutorial online to do it. So that's not a way to prove to me that you've done work. You can't prove it to me by showing me some ridiculously complicated app full of lines of code, because it's not easy for me to check your work. It's just a whole bunch of gibberish. But you can prove it to me by making something that is simple to use and understandable to use up front, but that I can tell took some work and some complication on the back end. And if that includes you telling a bit of a story of how you did it, if that includes you saying, oh, like, I took a bunch of pictures of my friends right before they went to bed and I rated them from 1 to 10 on tiredness and stuff like that, that's even better. That's an interesting story about what you've done. And it's additional proof of what you've built in a way that's quick to understand and entertaining to me. That's really what it all comes down to.
And I think this speaks to the importance, maybe the last point to touch on this is the importance of full stack data science projects, and just how so many data science projects, I mean, like the number of Jupyter notebooks that import pandas, scikit-learn, and seaborn or matplotlib, and just like rehash what is basically the same flow every time is just, it's insane. Like I see so many people who have like half a dozen of these projects. It's like they just keep going back to Kaggle, and they hope that maybe if I do the same thing on a different data set again, that eventually somebody's going to notice. And the problem is, it's like no one cares, because that's right now the norm. It's the median applicant has this Jupyter notebook full of pandas, scikit-learn stuff, and they're not taking it any level beyond that. And that's where, you know, we put a lot of emphasis obviously on full stack data science. So everything from, we've talked about data collection, but also then the deployment of your model, of your app essentially on the cloud, on Heroku, AWS, or whatever, and exposing it so that people can just go to a website and play with it. And then you can literally put it in front of a recruiter, or you can put it in front of somebody at an interview and say, hey, look at this thing that I built. It's like, I've got to be good because I made a thing that does some stuff. So one thing I want to do is also touch on the other focus of these conversations. Obviously, we're recording this one after we've had a couple already, but so those ones, in every case, we took some time to talk about the future of AI, and I want to make sure we touch on that here. So first off, I guess I want to get your thoughts, because we've done a lot of these conversations with people at Kindred, with people at Google, with people at Google Brain and all that stuff at the cutting edge. You guys have heard a lot of that input. What's your take on AGI, artificial general intelligence, the singularity, whatever you want to call it? When is that going to happen?
I'll answer the same way it seems to me that everyone in the field at least answers. Yeah, it's probably going to happen somewhere between the next 10 to 100 years, right? And that's like pretty much all I can say about it. Just based on the current state of technology is nowhere close, but the pace is just constantly increasing. So it seems inevitable that we'll get to some AGI, but there's like a huge series of breakthroughs that need to happen before that happens. So I think a lot of people are aware of the current state of the field and think worrying about it is just like a waste of time. Then there's the other camp that says, well, Yeah, just because it's not going to happen immediately, we should still be preparing for this. 100 years is still enough time to worry about the existential risk of AGI.
Yeah, I my timeline's about the same as Russell's. I'd say probably between 2 and 100 years, but that's just me. I mean, to be honest, there's nothing in my experience that says it could be anywhere. It couldn't be anywhere from 6 months to 100 years. The thing is, like, the evidence from history that you look at of like how far away did we think a big breakthrough was just a few years or a few months before it happened is pretty scary when you look at it that way. Because if you look at, for example, the like heavier than air flight, the Wright brothers thought that it couldn't be done just 3 years before they did it. Even after the flight had actually happened, there were experts in the field that were like, no, it will never happen. It is totally impossible. And there were planes flying around overhead, like proverbially. And the reason that happened, of course, is communication was slower back then. So you could have a momentous event like this happen, but the experts in the field didn't know it. And similarly, atomic fission, like the nuclear power, was thought that it was given like a 90% chance of not being possible by Enrico Fermi, the guy who did it 3 years before he did it. So when an expert tells you, this giant leap in the field is 10 years away, that's like a psychological proxy to them of saying, I can't see right now the series of steps that it would take me to get there. So unless you're, in a part of the absolute inner sanctum of the one place that is going to make the breakthrough, because progress is driven by the peak of knowledge, right? It's not driven by the average knowledge. Even we who know like something about this field, we're not at the very absolute peak of knowledge. Like today, what is the very latest thing that has been done in the lab and not published yet? So we, from our point of view, we don't know. It could be that the final experiment is already underway and we're just not aware. That's absolutely possible.
Maybe to that point, we also don't know what's going on. Like, well, I guess maybe this is what you were talking about. We don't know what's going on inside Google HQ, like at Google Brain today, or at Twitter Cortex. Like things are happening behind closed doors, and maybe we should talk about this too, because there are ethical questions that come up immediately once you start talking about these things. But I think one other ingredient to this, and maybe this is the most extreme position on the early warning side of the AGI piece. With Russell, maybe you're at one end, Ed, you're maybe in the middle somewhere, and if I'm going to stake out this position, I guess that makes me more extreme. Is that maybe the technology already exists? Maybe we have all the ingredients already today. Maybe we're not waiting for a new kind of neural network or a different RL algorithm or whatever. Maybe we can actually combine stuff that already exists, add more compute power, add more data, and we can effectively get something that's most of the way there. Now, I think this is obviously just by combining stuff, you do end up with new models. So this is a definitional game a little bit, but we certainly have seen, for example, with OpenAI's GPT-2 paper, that was a great example of like GPT-1 was, I won't say unremarkable, but it produced results that certainly were nowhere near where we got with GPT-2, which functionally was just a juiced up version of the same model with fed more data, given more horsepower, more compute power. To train on, and all of a sudden it's doing things with terrifying accuracy. So, like, I'm somewhat sympathetic to an argument that says maybe we already have the ingredients. Maybe we're not waiting for the next evolution of what Jeff Hinton might say is a completely new rethinking of the whole paradigm. Maybe everything is already in place, and we just need to keep playing with the pieces. It's a terrifying thought, but it could be true. I'm more in Russell's camp in terms of like, I'm not going to pretend to know that this is the case. I've just heard this argued. So I'm tossing that out there. And I honestly, I don't think, I agree. I don't think anyone can really know. But okay, so onto the more ethical question. When we've talked about stuff happening behind closed doors, in some ways, this is related to questions that people have about social media and like who's running the algorithms there, because these are black boxes basically. But there's also the question of the amount of power that not social media, but like that whatever company that builds an AGI is going to have, and the fact that by definition it won't be crowdsourced. I mean, there's going to be a small group of people who are going to have access to this when it comes out, and they'll be feeding it the training data. And whoever has control of that training data is exerting a level of control over the future of human civilization that is maybe inappropriate, but I can't think of a way to sort of stop that. Do you guys have any thoughts on like how that could be prevented, whether it can be prevented?
Well, so here's where I think AGI is like a red herring, because like that problem you described is already happening, right? We are like Google, Facebook, and the like already have algorithms and the training data that are like insanely good at predicting our next move. Like it doesn't have to be AGI in order to have these sort of ethical questions. It's just the predictive power you get from some of these algorithms plus all of mankind's data is that kind of power is a little frightening, because you can now like predict with accuracy, you know, how people's political preferences can be manipulated, how you can manipulate people into buying things or performing actions you want them to do based on the content that you feed them. The worrying thing is that I guess that our brains are more hackable than we think by the current state of machine learning rather than some distant AGI.
Here's a question to double down on that. So let's say that Twitter or Facebook or whatever has a machine learning model that's designed to figure out your political views. And let's say that based on demographic information alone, not the content that you share, but just your demographic data, it's able to peg you down to exactly the political views that you actually hold. Does that make you change your mind on your political views?
I have a really annoying answer to that question.
Yeah, shoot.
So if it is actually true that you can predict someone's political views based on demographic information alone, then doesn't that logically mean that I can't change my political views if my demographics don't change?
The answer is move to your preferred political demographic.
Move to another city and then change your political views is the answer.
And that's how bubbles are formed.
So maybe I can reframe the question a little bit. Like, let's say the algorithm could 90% accurately predict the political views of someone in my demographic, and it did so for me. Then I would think about that and I would go, okay, well, I know that I was basically randomly spawned on this map of the world somehow, according to just complete chance. Should the place and circumstances of my birth determine what my opinions about every other person who's been birthed be? Maybe they shouldn't. They definitely give me a perspective that not, most people outside my demographic may not share unless they make the effort to understand it. But I definitely don't feel like that should control my views to a huge extent. So I would definitely rethink my views if I knew that my political views were predictable just directly as the output of my demographics.
Well, as a follow-on question, do you think that's the case for most people? Because I mean, I certainly do. I think you can make a pretty good classifier for political preference. Obviously, in the U.S., it's even easier. You got two parties, so just based on demographic information alone. I mean, the disturbing implication of this is that most people just aren't thinking.
But some people do choose their demographics. That's another the tribes that you join, especially on the internet. Those tribes have become fungible. Like it used to be, like you're born in a village, you're born in an ethnicity, you're born in a place. That's who you are. You have this national identity, you have this ethnic identity, you have this and that, and people still have those things, of course. But I choose to follow certain people on Twitter, right? I choose to accept certain LinkedIn requests and not to accept others. Like I choose the circle of peers that I surround myself with, so that I think that there's an intentional coupling that goes on there too, because I'm not just like seeing these people and then absorbing their views passively. I'm seeing some people, absorbing some of their views, rejecting some of their other views, choosing the next set of friends that I have based on my analysis of the previous number of people, and then iterating back and forth on that. So I think that while, algorithms are definitely shaping all of that too, I think there's room for intentionality in the process.
There's room for sure, but I think like that whole process for a lot of us is largely moderated by algorithms, right? Like who shows up in my suggested people to follow, which of their tweets surface, which tweets of my like third and second connections are shown to me in my Twitter feed. There's I think we often have less control than we think. Which is a really pessimistic way to look at these things when it comes to controlling the content of your Twitter feed.
Well, and I couldn't agree more. And I think that the sad reality is that the world is such a high dimensional place that there's no possible way that any individual is going to have the time that it takes to peruse through Twitter and pull out the things that would be interesting. In other words, there's always going to be, like, to have a coherent product, Twitter needs some kind of recommendation engine. There needs to be a form of dimensionality reduction that's done for us. And by the way, maybe a more dramatic example of this is journalism. Like, journalists have a sacred duty. And the reason they have such a sacred duty is that we take for granted the fact that every citizen in a country does not have the time to go out on the street and look into every issue that is of interest to them for themselves to draw their own conclusions firsthand. So someone is going to have to go out there and do the dimensionality reduction for us, to look at all the details, to read reams and reams of documents about the latest scandal in politics or whatever. Reduce that dimensionality down to an article, a blog post, a paragraph, or a tweet that we then consume. And if we're going to consume that thing that's already been dimensionality reduced for us, this is like model stacking, we have to assume that that first step was done in good faith. And the moment that you have journalists who don't do things like that in good faith, or who produce a skewed picture, whose dimensionality reduction passes through a filter that they don't make obvious and open to the public, then they're poisoning something at a level that you have no way to verify. Like, you're never going to go back to see the original features that they did dimensionality reduction on. You don't have time to read an entire bill or to read up on a scandal full out. You have to rely on this stuff. And so we as a society, I think it's fair to say, we're kind of like a giant organism where different layers of abstraction, different layers of dimensionality reduction are taken care of by different individuals who are specialized in those areas, but our institutions depend on that being done in a reliable and repeatable way. I think that's why journalism is such a sacred trust, really, and why Twitter and Facebook, those recommendation algorithms, are also, like, they're so important. They have to do things objectively, even though that's, unfortunately, like, I don't even know what objectively means in that context.
Yeah, it's, I guess, the loss function, or what are they trying to optimize, but when they show us stuff. And it's not optimize the clearest picture of the world for each person. It's like optimize the amount of time they're spending on our platform.
Yeah, optimize ad revenue, optimize clicks.
Yeah, and that just leads to, bad outcomes, because it's not in our interest that these algorithms are tuned for.
Are you guys surprised that, because naively I would have thought if the year was 2000 and you asked me, like, so we're going to make this software product where people just, like, scroll through a bunch of, like, random snippets of text and people will get really into it. What is the average emotion going to be of people who are, like, big time users of this platform? I think my guess would have been like, oh, I think they'll be really happy about it. I think they'll share uplifting messages. Like, obviously that's not what's happened. Are you guys surprised by that, or am I naive?
Yeah, it's hard to imagine a world before, like, news feeds, to be honest. They've quickly moved into, like, just a part of our culture.
It's only really been 10, 12 years.
Yeah, it's a short amount of time. That's kind of wild to think about. I would imagine people would have been bored. Like, do you really want to hear what random people in the world, their opinions on everything? Like,
it's funny. It does sound terrible when you just describe it in words.
But I feel like the fact that that's counterintuitive itself. I mean, like, humans have such a bad understanding of their own minds and their own loss functions that, like, the idea that we build an AI that does anything is almost terrifying, because like we can't even wrap our minds around how we're going to behave in a fairly, I mean, I would have thought the idea of just reading this content, that's a fairly like predictable context, and yet our behavior is totally different from what I would have ever expected it to be.
One of the things that blows me away constantly is how much markets exist. Like how much there's categories of people who want stuff that you would never imagine until it existed. Like there's an entire category of people on YouTube that love watching videos of other people eating dinner and talking. That's an entire thing, and it's a revenue generating model on YouTube with people making six figures from eating dinner and talking, and like that exists. There's a bunch of people who are like really really into that, and cool. That's cool. That's awesome. But I would never have guessed that in a million years before YouTube. And you can tell that nobody would ever in a million years have guessed it before, because back before content was user driven, back when there were gatekeepers like, NBC, ABC, all the big studios, it never occurred to any of them to create, a form of content that was like this. It never occurred to them to be like, why don't we just have a person eat dinner and talk to the camera? Like that never made it past the pilot in the pitches, right? So like the only way to tell what people really want is just to try a bunch of stuff and see what people end up clicking with. We don't know ourselves that well.
Yeah, and maybe that highlights the importance of introspection too. You might ask yourself, like, do I really want to be on Twitter? Like, which version of me wants to be on Twitter and which doesn't? Because I can tell you, part of me doesn't want to be on Twitter at all, but part of me really wants to be on Twitter. And there's like an addictive behavior in the short-term me versus long-term me, or my limbic system versus my cortex, or however you want to frame that. That sort of battle is something that I think most people aren't super conscious of, but it leads to different products. All right, I think we've covered a lot of ground already, and I mean, maybe this is a good teaser for the kinds of conversations that we already know we've been having, because this is not the first recording that we made. But stay tuned, guys, for more stuff like this, I guess. I mean, we were chatting with people from Amazon, Google, pretty well every name brand company out there in deep learning and data analytics, getting the insights of industry insiders, both how to proceed with your career plans and also on the future of the space as a whole. So stay tuned, and we will be doing a lot more of these in the future.